Ladies and gentlemen, please welcome our next speaker, Borys Neselovskyi, presenting the topic, PostgreSQL in Kubernetes, Operation Day 2.
This is really fine. Please raise a hand if you have experiences with Postgres database. Nice, nice. Please raise your hand if you have experiences with Kubernetes, OpenShift. Okay, we are the right team on the right place in the right time. Let's go. Okay, my name is Borys Neselovskyi. I'm living in Germany. I was born in Ukraine, in very nice city Odessa. And the last almost 30 years I'm working in IT with databases. I started with Oracle database, Oracle middleware. I'm really love to work in the communities, and I'm member from Germany Oracle user group middleware community. I am leading the community. I was Oracle Ace, but 4 years ago I changed my career. I am choose the way to open source, to Postgres database. I joined EDB, and I'm helping my customer to adopt the open source strategy, and especially in the Postgres area. And Postgres is most popular database in the world, by developers. And 4 years ago, in meetings with my customer, I was used to explain what is Postgres, why is Postgres good, why the user should use Postgres and not Oracle. But now all companies have Postgres strategy, and this is really very interesting development. Postgres is the database of the year, and I'm working for EDB, Enterprise DB, and we are really very important part of the community. Almost or more as 30% of code in Postgres is written by my colleagues, and from 7 person in core member, core team member, 3 are from us. Therefore, we know Postgres, we know Kubernetes, and we are really able to build something very nice, what I will speak about. Okay, Postgres operator. Let's start. Honestly, we started to build operator late because it was crunchy, it was Zalando. They built operator 4 years ago, and all customers used it, loved it. But we did it in the different way. We did it really cloud native. We developed it in Go language. It means that we can interact. Our operator can interact directly to the Kubernetes API. We don't need third-party tools for high availability. For example, Petroni. We are not using stateful sets. Stateful sets in Kubernetes for stateful operation is default technology. We don't use it because this is not flexible enough. We cannot resize our storage on the fly, and we adapted different several techniques, what is really very new. And for example, our operator is using by Google GCP, Google Cloud provider, and they are using our operator, and we are working together. We have Cloud Native PG is open source. You can just go to GitHub, you can download it, you can test it, you can use it. It's everything fine. We developed it, and we made it available for the community as open source. But we have a fork of the community. We have our proprietary operator based on the Cloud Native PG. If you need some advanced security options, for example, or if you need transparent data encryption on the database level, OpenShift compatibility, and so on, you can choose our operator. But Cloud Native PG have the almost the same features as our operator. And in the last year, we was really, according to timescale, our operator was popularest operator in the world. Yeah, we have 25 million downloads, 3,000 stars, and with stars, yeah, you can see here we are red. We have now almost the same number of stars as Crunchy and Zalando, but in very short time. And let's speak about what is the difference. Why do you need to use operator? Why do you need to use Kubernetes? In the classic world, yeah, to create one Postgres cluster with 3 nodes, with one master, 2 standbys, I need to execute several steps. I need to create VMs, I need to install Postgres, I need to configure streaming replication, I need to set up backup, to test my recovery, to create, configure monitoring, security, and so on. You can, of course, automate these tasks, but it's everything installation steps, and you will have some problems. You need to investigate some troubleshooting and so on. You need to maintain your code and adapt to new requirements, to new versions, to new changing settings, and so on. In the declarative way, what we have in our operator, to create 3 nodes cluster, you need just this YAML file. You will not install it, you will just start deployment, and operator will download the image, immutable image with Postgres, and in 2 or 3 minutes, and you will see it, you will have your cluster with security, with monitoring, with everything, backup, recovery, everything is there. And this is really the unique selling point and added value for you. You can make all operations, backup, recovery, monitoring, high availability, failover, switchover, and so on, just with YAML syntax. You don't need to execute, to know each tool, to execute any command. It's everything in Kubernetes automated for you. And as I already said, our operator have several features. For example, we rely on Kubernetes self-healing capabilities, and we build it failover just to operator, because honest EDB created for Postgres streaming replication and logical replication. We know how it works, and we know what we need to implement to the operator to make failover, and we implemented it to operator. I will show you how it works on the example. You can scale your memory and CPUs on the fly for Postgres instances, and you can scale as well your read replicas. Yeah, your read workloads you can scale. You can start more replicas than stop. You can make rolling upgrades. For example, minor upgrades of Postgres from version, for example, 15.3 to 15.4. You can just change YAML syntax version of Postgres, and it will be running in rolling manner and make you upgrade. You can make backup and recovery, and as well point-in-time recovery, just with YAML syntax. We have Prometheus exporter, we have Grafana dashboards. We can create geo-distributed Kubernetes clusters and make it one primary cluster, one standby cluster, and replicate data and make geo redundancy and more. Installation of operator is just, you can use a Helm chart, or you can install manifest. It's just deployment. It's not the big deal here. And to create the cluster with 3 nodes, one is master, 2 standby, with TLS authentication for replica. It means that the replication will be encrypted. You need just to have one YAML file, and it could be YAML file with this syntax. You need to provide your name of the cluster. You need to provide some informations. For example, if you want to have synchronous replication with you, and you will not lose the data, you can set min, max sync replicas. You can set different storage classes for different database areas. Yeah, for PG data, for vol storage, and for table spaces if you decide to create some table spaces. You can set several database parameters. You can as well set pghba.conf here. You can create LDAP or AD authentication. Yeah, everything is possible, and only you need to create your YAML files. And then you can just run kubectl, and your cluster will be created. What will be created? At first, it will be created the storage units. For the node 1, it will be started Postgres. This will be the master or primary. And the read-write service will be created. Read-write service point always on the primary. If my primary is changed, the service will be reconfigured and show on the new primary. It means that you need to provide to your clients to access the primary read-write only the IP address or server name of the service. Yeah, and it will be not changed. Then it will be started the first replica. Replication will be configured, everything automatically. Read-only service will be started. If you will to provide for your clients read-only access, yeah, for selects, for some reports, they don't need to have access to the master database, yeah, because you can just isolate read-write workloads from read-only and provide the connect string to the replica. Third replica will be created, replication will be configured, and everything is good. If your primary fails, what's happened? Operator make failover completely automatically because they receive the message from Kubernetes, your replica is not available. The standby database will become the role of primary. Operator will start replication for the new primary to the existing standby and create from old primary the new replica and start the replication. And this is what I would say is big advantage of Kubernetes, yeah, because if you have a classic environment with VMs and you have such situations, yeah, you need third-party tool to be sure that your primary, if it fails, you can start the replica. You need to monitor everything. Yeah, here the Kubernetes and operator will do it for you. And of course, in this architecture, we have mostly, yeah, if we are thinking in the cloud vendor wording, yeah, we have the region with free availability zones. With free region is city, availability zone is data center. But if we have some problem with our city, with our region, yeah, you can see now in the Ukraine, yeah, the whole city is going down, and yeah, we need some time geo redundancy. And to create the geo redundancy, yeah, we can create several clusters, 2 clusters, for example, and make replica cluster. For example, I have in Vilnius my first cluster, Kubernetes cluster with my primary 2 standbys. I have backup to S3 storage, and everything is good. I can create from this backup the cluster in the different city. in Kaunas, for example. Yeah, I can create it, and I can synchronize my cluster in two ways. I can replicate the WOL files from my primary cluster to my replica cluster, or I can replicate the WOL files from the backups. And then I can create high availability in Kaunas, for example. I can create second and third standbys. And if my primary cluster fails, I need just to change one parameter on the replica cluster to start it as primary. And then I can start replication in a different way. Yeah, in this way, we have, in this architecture, we have two Kubernetes cluster, two Postgres cluster, that will be synchronized. Everything is in YAML syntax implemented, and you don't need to create to type some commands. If you need some advanced security options, yeah, for example, extended auditing clock. If you need in banking sector, you need to mask some information, for example, credit card number, and show only 4 last digits. Encryption, yeah, we have it in our proprietary version of operator, and you can use it if you have more security requirements. Okay, let's talk about main capabilities. Storage. From my experience, we have several customers who said, okay, we have already Kubernetes. Yeah, we have applications in Kubernetes web server. It's running very, very nice, but we treat to run databases in Kubernetes, and it fails. Its performance was mess, and the first thing is in Kubernetes is storage. Yeah, which storage can you attach to your Kubernetes? Because this is very essential question. Yeah, and we are providing for you really the flexibility. You can use local storage, what is, from my opinion, the best way if you attach the local storage to the worker nodes, and then you have mission critical database, and you have only one pod on the worker node. You can achieve the same storage performance as by bare metal or virtual machines. Yeah, because you are not sharing storage, you are not fighting for several from several databases, several applications for one storage. But you can use network storage, and we support persistent volume claims and storage classes. It means that you can attach your storage, you can provide it to Kubernetes as storage classes, and you can have different storage classes for different database areas. For example, SSD for WOL files, yeah, or for PG data. You can choose different storage classes and be flexible. It's a very important point. I showed you 3 worker nodes, 3 Postgres instances. Yeah, we are trying to check how many worker nodes you have. Yeah, how many worker nodes are available for Postgres, and we are placing Postgres instances on different worker nodes. You can, with pod affinity, anti-affinity rules, node selectors, you can decide which worker nodes are available for Postgres or not. You can create your databases on different ways. With initDB, you will create the new cluster. Yeah, completely new cluster in Kubernetes. But you can as well import your cluster from existing Postgres instances. You can use pgdump and pgrestore. You don't need to try pgdump. It will be just a section in Bootstrap, and you can just migrate your database from non-Kubernetes, for example, into Kubernetes, and we can create the database from existing backup. We can try backups About backup I will be talk a little bit later. And you can restore your database from backup, make full restore or point-in-time recovery. And if you need to read more, my colleague wrote very good blog post about this. Rolling upgrades. It's very important point. You need sometime upgrade your environment. And we are supporting rolling upgrades. The standbys will be upgraded, and then the master or primary. Minor release upgrades can be run completely automatically. I will show you. I will upgrade my cluster, and its upgrade is just replacing of the image. Yeah, we will replace old image with the new image, and in this way you can make, for example, and the pods will be restarted. Yeah, you can make security fixes if you need to update your Kubernetes platform, and if you have the long-running upgrades, you can use supervised or unsupervised features. With supervised, you will decide the time where the node can be go down for upgrade. Backup and recovery. As the different operator, you can make backup and backup to S3 storage. Yeah, we are supporting all S3 compatible storage, and you can write the WAL files to S3 storage and make the full backups. Restore, you can do it full and point-in-time recovery. But we have some problems with S3 storage. The first problem is for our customers, they have 10 terabyte database. And the database Kubernetes cluster was done and lost, and they have to restore the database, 10 terabyte database from the S3 storage. It took 2 days time. And the customer breached the SLAs for a recovery time object, for example, objective. And we created, now we are supporting the Kubernetes volume snapshots. Yeah, you can just write in YAML syntax, make me backup of my database with Kubernetes volume snapshots. And we have some advantages. Yeah, for example, we can now make with snapshots incremental and differential backups. We can move these snapshots across different clusters and create other cluster from this snapshot. And this is very good fits for very large databases by restore. Here you can see some numbers, and if you see the large database, we started with 4 terabyte database, and we run the PG bench, and yeah, we have the database is grown to 8 terabyte, and we made the backup with snapshot. The first backup was done in almost 4 hours, second backup in 2 hours, and the recovery of this 8 terabyte database took 2 minutes. Yeah, and this is really big difference to classic backups. Yeah, and this is the feature that our customer need really, and now use it for very large databases. We have native Prometheus exporter with several metrics, but I will show you this in my demo. We have Grafana dashboard. You can just download from our documentation JSON Grafana JSON file and start it and use it as a template, for example, yeah, and implement your own. Logging is very important thing because yeah, all informations from Postgres, yeah, for example, database log informations, but as well auditing log will be forwarded to standard output, and you can collect with your tools the log informations from the standard output. CNPG plugin is very good tool. We created extension for kubectl or OC if you are using OpenShift to make some things, for example, to maintain your TLS certificates, to start Postgres, stop Postgres, to start pod, stop pod, to make pgbench, for example, to test my performance, and several other things. Yeah, you can start as well pgadmin with this plugin. And we have, if you have databases with OLTP, for example, with big amount, big number of customer, yeah, and customer will access database, log into database, make something, then yeah, close the session. You need some connection pooling manager, and Postgres is PG Bouncer, is very well connection pool manager, and we created operator for PG Bouncer. You can just with one YAML file create some instances of PG Bouncer and then manage your connection pooling. Okay, and now I think I will show you the demo. I have my Kubernetes cluster on my laptop. Yeah, I know it's not. Ah, this one. Or I can maybe, I don't know why, but this one is. Ca can you see or? Okay. Okay, I have my Kubernetes cluster running on my laptop. Is Cadra K3S. And yeah, and now I will in the first step create install the plugin what I talk about this. Installing of plugin is just to execute the script from Cloud Native PG, and we will be able to use kubectl with extended syntax, and your plugin will be now installed. Okay. The second step is installing of operator. As I already said, operator is just deployment in Kubernetes, and you can install operator with Helm charts or with installing of manifest. It's really straightforward, and now we are really able to create our first cluster. I will check if the operator installation is ready. Is not at the moment, but we can create our first YAML file. Everything what you need to use the operator is kubectl or OC and YAML syntax. And we need to make. Okay. I will create now the YAML file, and as you can see, I have the cluster name, cluster example. I have 3 instances, 1 master and 2 standbys. I will create it with Postgres version 15.3, and I will just enable the Prometheus monitoring. Okay, I will check again if the operator is now ready, and now just yeah, we can create our first cluster. What has happened? Let's see. The operator will provision the storage, and then will download the image. Will pull the image, and here I will start plugging kubectl CNPG status my cluster and see what is happening. Yeah, I'm pulling image from internet, from my mobile phone. My mobile phone. That I think we need some seconds, 10-20 seconds to pull the image. After pulling the image, they will start the first instance, master instance, and create the service. Point my master to read-write service. In the second step will be create the first standby, then third standby, and everything will be good here. But now we are pulling image. Maybe I can, okay, now is image already there. The first node cluster will be started Postgres, and here we can see what we have, the cluster example 1 pod. It's a primary database, and we will now the operator creates the second pod, a standby. You can see we have standby in async mode because I didn't create sync replication. And yeah, the storage will be created for the third node, and this node will be started. And now we have our cluster, 3 nodes cluster in 2 or 3 minutes with everything what we created already. We have 3 node cluster. We have services, read write and read only, what I already spoke about this. We have secrets. We have TLS certificates for replication. Our replication is encrypted. We have TLS certificate for the client access. And we have a secret for super user access and app access. You can create your own user, you can import your own certificates, everything you can customize, but we will create for you these all things. And the cluster is there. Okay, let me show how can we monitor the cluster. I will just create the Prometheus rules. This syntax is, everything is described in the documentation. Yeah, we have Prometheus rules, and now I need to just to start port forwarding and show you how it works. I'm going to Prometheus, and I just searching for CNPG, and you can see here about, I think, 200 metrics with alerts, and we are monitoring the whole things. Postgres, streaming replication, high availability, everything is there. If you need to create your own metrics, we described it in the documentation how can you do it. And we have here a Prometheus export already configured for you. Now I will create you Grafana dashboard. Grafana dashboard we have in the documentation. You can download it. Oops, something is wrong. And I can just go to dashboards, and I can import my JSON file here. I need to check the Prometheus data source default, and I have my dashboard. Yeah, we have several sections and some data. We need to have time to fill out everything, but you can see the cluster level, version, information of pod, CPU utilization, memory utilization, lag, replication, and so on. You can see server health, you can see configuration, for example, all parameters, and you can see CPU usage, session state, and several other things. Storage, write a hit log is very important. If you have some problems, performance problems, I would always at first see to write a hit log. Replication status, backup, and so on. We have this Grafana dashboard. It can be good for you. Maybe you need to adjust something or use other different, but we have Prometheus exporter and Grafana. Yeah, and everything is there. But now I would like to show you some interesting things. I will create one table. I need to go back and create a table test with 1000 rows. I will check it, and I have my table test and with 1000 rows. Now I will show how can I change the roles. I would say my cluster example 2 to primary and cluster example 1 to standby, make switchover. To make switchover, we have the command with plugin kubectl cnpg promote cluster example to cluster example 2. If I try this command, you can see that cluster example 2 will be primary, and then cluster example 1 will be starting as standby, and operator configure replication from the new primary to standbys. Everything is good, yeah. And you can do it, for example, if you need to upgrade your some firmware, Kubernetes version, or something else. But now I will simulate the failover situation. I will start now. I will just delete my master pod. Cluster example 2 is primary, and I will just delete it. And let's check what is happening. Kubernetes detects that the pod is not available. Operator make cluster example 1 as primary, make failover, and operator is starting failed master as the new standby and configured replication from the new master. You can see it's happened automatically. Yeah, you don't need to make something. If your pod is down, operator will take care about this situation. I don't know why, but sometimes they need some time to create replication, and I can maybe help him to create. If I can switch a vol file, let's see. kubectl plugin. You can see that the plugin, you can do several operations. You can make backup your database. You can maintain your certificates. Yeah, you can destroy cluster, fencing, flexible I/O. You can test your performance of your storage, for example. You can hibernate. You can run pgadmin, pgbench, PSQL, and several other things you can do with plugin. Is just extension to kubectl. And yeah, it's very good thing to do it. Good. Okay. Now I would like to show you kubectl status command in the and the full output to show what is the status of our cluster. We can see that the cluster is in the health state now. Version is 15.3. We have expiration date for our certificates. Yeah. We don't have now continuous backup and physical backups and all other informations you can see. Now I created 5 minutes. Ah, nice, nice. I created now the different YAML file called cluster example upgrade, and as you can see, I will do a minor upgrade of Postgres. I will change from 15.3 to 15.4, and I will add the backup section. I will provide S3 access, storage access. I have my S3 storage here, and I don't have any buckets at the moment. And now I will run the upgrade. As you can see, the operator make running upgrade take the first standby and replace the image. Yeah, now they make pooling of the 15.4 image, and if the image is pulled, they will replace image on the first standby. Then they will take the second standby, and at the last but not least, the master. You can choose if your master, if you will have switchover, if you can switch over and then upgrade. In the default, it will be master just restarted, yeah, with the new image. And now we can see the example 3 is now patched, and the second node will be started with the new image, and the last will be our primary replaced image will be replaced. Okay, now we have our cluster upgraded, and if we are looking now for status of the cluster, we can see that we have now 15.4. I changed just the parameter, the instance, and we have now backup. We have backup of vol files. It means that our min IO storage have now directory CNP and cluster example, and the vol backups will be just archived to S3 storage. Full backup you can do with YAML syntax. You need to create YAML file with kind backup. You need to take name backup test, which cluster, and you can make, for example, scheduling as well. I will run a one-time backup, but you can schedule the backups. And backup is completed now, and in the S3 storage we can see in cluster example the second base directory with our backup. And to restore my backup is always the out of the place restore. I will create the new cluster, new YAML file, cluster restore with one instance, and it will create the new cluster with the full restore. You can make full point-in-time recovery. You can provide the line with time or sequence number and make it with not all vol files applying. And yeah, now my pod will be initialized, and at the end I will have my restore cluster. And you can remember I have the table test with 1000 rows, and I will check in my cluster restore now if my table is available, and you can see that I restored my cluster. 2 minutes. Okay, I am almost ready. I would like to show you how easy it is to maintain, to run Postgres and Kubernetes. Please use our operator. You have some questions, I am available for discussions, and we at CDB are available for. Thank you very much.
Thank you, Boris. So I don't think we have too much time for all the questions. So please Do remember to ask questions on Slido during the talk, or also if anybody in the audience has something to ask right now, please raise your hand. Yes?
Can we have active cluster with Postgres?
Yes, yes, you can. We by EDB have Postgres distributed as multi-master based on logical replication with conflict resolution framework. We talked already today, and we have it on Kubernetes. It's not open source; it's closed source. But you can, if you have interest, we can speak about this in more details.
Of course, feel free to catch up with Borys in pauses and other days to have more in-depth conversations. One more question?
Yeah, yeah.
In the meantime, more questions? Or no? Please do. I will repeat. Do you support any extensions like timescale, DB, or anything else on this operator?
Yes, yes. We are supporting almost. I don't know the all contrib extensions, timescale DB extension as well, and several other extensions. PG Vector, for example. Yeah, and yeah.
Thank you. More questions? Yes. Oh, there is a microphone coming.
Very quick one. Does it roll back automatically as well if upgrade fails?
It's just upgrade. We need to talk about different upgrades. Yeah. For example, minor upgrade is replacing of image. Yeah. If you make major upgrade, we have different techniques. For example, one of technique is pgdump pgrestore with YAML file. Second is to create logical replication, what we can also support with YAML file. And we have now in place major upgrade, but it's dangerous. We are not recommended to do it because you need to test if you fails, it's not automatically fail, or you need to be care about your fallback scenario.
Okay. So, but in the situation which you demoed, switching from 15.3 to 15.4, if one of the replicas is terminated and it's not able, I mean, it doesn't spin up for reasons. Can it recognize that it's not, that the minor upgrade is not going well and just stop it?
Yeah, if you are not in sync, if your status is not in sync, it will be say you cannot upgrade, because this is for this unsupervised rolling upgrade. The first prerequisite is to have sync status.
Okay, thank you.